Hello. For as long as we have looked up at the night sky, we have populated it with myths. In ancient times, we saw gods, heroes, and great monsters in the patterns of the stars. They were beautiful stories, our way of making sense of a vast and mysterious cosmos. Today, we live in a scientific age, but we haven't stopped telling stories. We have a new kind of mythology, a folklore born from the silver screen of science fiction, from half-remembered headlines and from our own intuition, trying to make sense of concepts that are almost too big to hold in our minds. These are the modern myths of space. Tonight, we are going to explore some of these myths, but this isn't going to be an aggressive debunking video. We're not here to scold or to make anyone feel foolish. Instead, let's think of it as a quiet, gentle process of unpacking. We'll look at a popular myth, appreciate why it's so compelling and why it makes intuitive sense, and then we'll slowly and calmly replace it with the scientific reality. And what I think we'll find is that the truth, while often less dramatic, is almost always more profound, more beautiful, and far stranger than the myth it replaces. So, let this be a soothing exploration of whispers and truths, a calm journey through our most common cosmic misconceptions. There's no need to follow every detail. Just let the ideas float by, like distant stars in the quiet of the night, and see where they take you. Let's begin.
Our first myth is one we all learn as children. It's the idea that space is completely empty. We call it the vacuum of space, and we imagine it as a perfect, absolute nothingness, an infinite void, utterly devoid of matter. It's a powerful and simple image, but it's not quite right. The quiet truth is that space is not empty. It's just the emptiest thing we know. There is a profound difference. Let's start with the space between the stars in our own galaxy, what's known as the interstellar medium. While it is a vacuum far better than any we can create in a laboratory on Earth, it is still filled with a thin, tenuous soup of particles. On average, there are a few stray atoms of hydrogen and helium in every cubic meter of space. It's not much, but over the vast distances between stars, it adds up. These thin clouds of gas are the very material from which new stars will one day be born. And it's not just gas. Space is also filled with a constant, invisible rain of high-energy particles we call cosmic rays, the shrapnel from distant supernovae. It's filled with ghostly, nearly massless particles called neutrinos, which pour out of the hearts of stars and pass through almost everything, including our own bodies, without a trace. And the entire universe is filled with a faint, uniform glow of microwave radiation, the ancient, cool afterglow of the Big Bang itself. But even all of that put together is just a tiny fraction of what's really out there. The greatest secret of the cosmic emptiness is that it is dominated by things we cannot see at all. About 85% of all the matter in the universe is the mysterious, invisible substance we call dark matter. It doesn't interact with light, so we can't see it, but its gravitational pull is what holds our galaxies together. And about 70% of the entire energy content of the universe is the even more mysterious dark energy, a force woven into the fabric of space-time itself that is pushing the cosmos apart. So the vacuum of space is not empty. It is a bustling, active place filled with invisible matter, mysterious energy, ancient light, and the seeds of future stars. It is a quiet, but very full kind of nothing.
Our second myth is closely related to the first. It's the idea that space is cold.
We see images of astronauts in bulky suits and imagine them fighting off a bitter, biting cold. And in a way, that's true. But the reality is much stranger and more dangerous. The concept of temperature in space is very different from on Earth. Here, we are surrounded by an atmosphere. The air molecules around us have a certain average energy, and that is what we measure as temperature. In the near-perfect vacuum of space, there are almost no molecules to measure. So, space itself doesn't really have a temperature in the way we normally think of it. Instead, the temperature of an object in space, like an astronaut or a spacecraft, is determined by a delicate balance between absorbing radiation and emitting it. And this leads to a world of brutal extremes. If you are in direct, unfiltered sunlight in space, you are being hit with a huge amount of radiant energy. With no atmosphere to scatter or absorb it, the surface of your spacesuit can quickly heat up to a blistering 120 degrees Celsius, well above the boiling point of water. You are essentially being cooked by the raw, unfiltered power of the sun. But the moment you drift into a shadow, the shadow of your own spaceship or the dark side of the moon, that equation flips completely. With no sunlight to heat you and no air to hold on to any warmth, your body heat radiates away into the infinite blackness with terrifying speed. The temperature of your spacesuit's surface will plummet just as quickly to a mind-numbing cold of minus 160 degrees Celsius. An astronaut on a spacewalk is constantly moving between these two extremes, an oven on one side, a deep freezer on the other. Their life depends on a complex system of water cooling tubes and electrical heaters in their suit, a personal thermostat constantly fighting to keep them in that tiny, perfect sliver of habitable temperature between two brutal extremes. Now for our third myth, perhaps the most dramatic and enduring myth from science fiction movies, the idea that if a human is exposed to the vacuum of space, they would instantly explode. It's a common scene. A helmet cracks, or an astronaut is thrown out of an airlock, and their body swells up and violently pops like a balloon. It's a graphic and memorable image, but it's scientifically incorrect. The human body is much more resilient than that. The truth is still deeply unpleasant and, of course, very quickly lethal, but it's a quieter, more subtle kind of horror. The main problem is not pressure from the inside pushing out, but the lack of pressure on the outside. The first thing that would happen is that the air in your lungs would be ripped out instantly. If you tried to hold your breath, the expanding air would rupture your lungs, which would be a fatal injury in itself. The next thing that would happen is a bizarre and terrifying phenomenon called ebullition. The pressure of the vacuum is so low that the boiling point of the liquids in your body would drop to your own body temperature. The moisture on your tongue and in your eyes would instantly boil away. The water in your soft tissues and your blood would start to form water vapor bubbles, causing your body to swell up to perhaps twice its normal size. But your skin is incredibly strong and elastic. It would hold you together. You would not explode. You would remain conscious for about 10 to 15 seconds until the oxygen-deprived blood reached your brain. After that, you would fall unconscious. Death would likely follow within a minute or two from a combination of asphyxiation and the effects of ebullition. It is a horrific and deadly environment, but the reality is a quiet, internal, and rapid shutdown, not a dramatic, explosive spectacle. All right, let's leave the immediate dangers of the vacuum and begin our tour of the solar system, starting with one of its most famous and most misunderstood regions. This is our fourth myth, that the asteroid belt is a dense, impassable swarm of rocks. I think we can all picture this one. In movies and video games, the asteroid belt is always depicted as a chaotic, crowded cosmic demolition derby. Our hero's spaceship has to frantically swerve and dodge through a dense field of giant tumbling boulders that are crashing into each other all around them. It's a thrilling and visually spectacular scene, but it is completely, utterly wrong. The quiet truth about the asteroid belt is that its defining characteristic is not its density, but its almost unimaginable emptiness. While it's true that there are millions of asteroids in the belt, from tiny pebbles to the dwarf planet Ceres, the volume of space they occupy is colossal. The belt is a vast, donut-shaped region between the orbits of Mars and Jupiter. The distances between the asteroids are immense. On average, the distance between any two asteroids, even small ones, is millions of kilometers. If you were standing on one asteroid, you would not be able to see the next one. It would be too small and too far away. The night sky from within the asteroid belt would look almost exactly like the night sky from Earth, just a vast blackness with distant twinkling stars. This is why every single spacecraft we have ever sent to the outer solar system, Pioneer, Voyager, Galileo, Cassini, New Horizons, Juno, has flown directly through the asteroid belt without any problems at all. The chances of a spacecraft accidentally hitting an asteroid, even a small one, are so infinitesimally small that mission planners don't even worry about it. It's estimated to be less than 1 in a billion. The asteroid belt is not a crowded field of rubble. It is a vast, quiet, and deeply lonely wilderness. Our fifth myth takes us to our closest celestial neighbor, the Moon. It's the idea of the dark side of the Moon. The name itself evokes a sense of mystery, a permanent, hidden realm of darkness. The idea is that there is one side of the Moon that is perpetually shrouded in night, never seeing the light of the sun. This is a very common and very old misconception, but the reality is much more straightforward, though still quite interesting. The truth is, there is no permanent dark side of the Moon. A much more accurate name is the far side. The reason we only ever see one face of the Moon from Earth is due to a phenomenon called synchronous rotation, or tidal locking. Over billions of years, the Earth's gravity has tugged on the Moon, causing its rotation to slow down until it reached a perfect equilibrium. Now the Moon rotates on its own axis in exactly the same amount of time it takes to complete one orbit around the Earth, about 27.3 days. Because its rotation period and its orbital period are the same hemisphere is always facing us. Imagine two dancers holding hands and spinning around. They are always facing each other. It's the same with the Earth and Moon, but this has nothing to do with sunlight. As the Moon orbits the Earth, all of its sides receive sunlight over the course of a lunar day, which is about 2 weeks long. The far side has its daytime when the Moon is in its new moon phase as seen from Earth, and it has its nighttime during the full moon phase. It gets just as much sunlight as the near side does, we just never get to see it from our perspective on Earth. For all of human history, the far side of the Moon was a complete mystery. It was a hidden landscape unseen by any human eye until 1959, when the Soviet Luna 3 probe flew around the back and took the first grainy pictures. We now have it mapped in great detail. It is a quiet, beautiful, and very cratered place, but it is not a land of eternal darkness. Now for our sixth cosmic misconception, a simple piece of solar system trivia that many people get wrong. This is the myth that Mercury is the hottest planet. This seems perfectly logical, doesn't it? Mercury is the innermost planet, the one closest to the sun's intense heat.
It stands to reason that it should have the highest surface temperature. And during its long daytime, its surface does get incredibly hot, reaching a blistering 430 degrees Celsius, hot enough to melt lead. But Mercury is not the hottest planet in the solar system. That title belongs to the second planet from the Sun, Venus. The quite surprising truth is that Venus is significantly hotter than Mercury, even though it is about twice as far from the Sun. The average surface temperature on Venus is a steady, uniform, and absolutely hellish 465 degrees Celsius, hot enough to melt lead. So why is Venus hotter? The answer lies in its atmosphere. Mercury has almost no atmosphere to speak of, so while its day side gets very hot, it has no way to trap that heat. During its long night, all that heat radiates back out into space, and the temperature plummets to a frigid minus 180 Celsius. Venus, on the other hand, has an incredibly thick and dense atmosphere, composed almost entirely of carbon dioxide, a potent greenhouse gas. This thick, toxic blanket acts like an insulator. Some light comes in and heats the planet's surface, but the carbon dioxide atmosphere traps that heat and doesn't let it escape. This is a runaway greenhouse effect. Over billions of years, this process has turned Venus into a planetary pressure cooker, with a surface that is hotter than the inside of a pizza oven, from its equator all the way to its poles, on both its day and night sides. It is a quiet lesson in planetary science. A planet's temperature is determined not just by its distance from its star, but by the properties of its atmosphere.
Our final myth in this first section is a very famous and persistent one, a claim that has been repeated in textbooks and trivia for decades. This is the myth that you can see the Great Wall of China from space. It's a wonderful, romantic idea. The thought that a single human-made structure is so vast and so significant that it is visible to the naked eye from orbit, or even from the moon. Unfortunately, as appealing as the idea is, it's simply not true. The Great Wall, while being incredibly long, is actually very narrow. It's only a few meters wide. From the altitude of low Earth orbit, say 400 kilometers up where the International Space Station flies, trying to see the Great Wall would be the equivalent of trying to see a single human hair from 2 miles away. It's just too thin to be resolved by the human eye. Astronauts have confirmed this many times. They have reported that they cannot see the wall with the naked eye. Under perfect conditions, with a zoom lens on a camera, and when the sun is at a low angle to cast long shadows, it is possible to pick out sections of the wall, but it is not an easy or obvious feature. And from the moon, 250,000 miles away, it is absolutely, completely invisible. In fact, from the moon, you can't see any man-made structures. The only signs of humanity you can see are the lights of the great cities on the night side of the planet. This myth likely started in the 18th century as a thought experiment, long before anyone had ever been to space. And it has persisted ever since because it's such a great story. But the quiet truth is that the works of nature, the continents, the oceans, the cloud patterns, are far more vast and visible from space than even the greatest works of humanity. All right, let's leave our own solar system behind now and zoom our perspective outwards to the stars and the vast cosmic structures they inhabit. The quiet misconceptions we have about these distant objects are just as fascinating. We'll start with our own star for myth number 8, the idea that the sun is yellow. When we are asked to draw a picture of the sun, most of us will reach for a yellow or an orange crayon. We see a yellow sun during the day and a beautiful orange or red sun during sunrise and sunset. So it seems perfectly logical that the sun itself is yellow. But this is a trick of our own atmosphere. The sun is, for all intents and purposes, a white star. It emits light across the entire visible spectrum with almost equal intensity.
When all these colors, red, orange, yellow, green, blue, violet, are combined, our eyes perceive the light as pure white. You can see the true color of the sun if you look at pictures taken from space, where it appears as a brilliant, intense white orb. So why does it look yellow to us here on the ground? The reason is a phenomenon called Rayleigh scattering. As the sun's white light passes through our atmosphere, the shorter wavelength blue and violet light is much more likely to be scattered by the nitrogen and oxygen molecules in the air. This scattering of blue light is what makes our sky blue. When you look at the sun directly, you are seeing the leftover light that wasn't scattered. With some of the blue light removed, the remaining light appears slightly more yellow to our eyes. And at sunrise and sunset, when the sunlight has to pass through much more atmosphere to reach us, even more of the blue and green light is scattered away, leaving only the beautiful, deep oranges and reds. So the color of our sun is a quiet, beautiful illusion created by our own planet's gentle blue sky.
Our ninth myth takes us into the night sky. It's the common belief that Polaris, the North Star, is the brightest star in the sky. Polaris is certainly the most famous star in the Northern Hemisphere sky. It's a celestial celebrity. We are taught from a young age how to find it, how it can be used for navigation because it sits almost directly above the Earth's North Pole, and so it never seems to move. Because it is so important and so famous, many people assume it must also be the brightest. But the quiet truth is that Polaris is only a moderately bright star. It's not even in the top 40 of the brightest stars we can see. On the scale of stellar brightness, it ranks at a humble number 48. The actual brightest star in our night sky is Sirius, also known as the Dog Star, located in the constellation Canis Major. Sirius is a brilliant blue-white star that is much closer to us than Polaris, and it shines more than 20 times brighter than our sun. It can be a truly dazzling sight in the winter sky. So why is Polaris so famous if it's not that bright? Its fame comes entirely from its special position. Because it lies almost exactly on the line of the Earth's rotational axis, the entire northern sky appears to revolve around it throughout the night. It is a quiet, steadfast, and reliable anchor point in the turning cosmos. It's a wonderful lesson that, in the sky, as in life, sometimes being consistent and reliable is more important than being the brightest. It's also worth noting that due to a slow wobble in the Earth's axis called precession, Polaris will not always be our North Star. In about 12,000 years, the brilliant star Vega will take its place.
Our 10th myth is another one about our perception of the stars. It's the idea that stars twinkle. We see it in nursery rhymes and in poetry. Twinkle, twinkle, little star. The twinkling of stars is a fundamental part of their romantic and beautiful image. But the twinkling is not coming from the star itself. It is, once again, a beautiful illusion created by our own atmosphere. A star is so incredibly far away that even in our most powerful telescopes, it is essentially a perfect single point of light. As the light from that distant point travels down to us, it has to pass through the Earth's turbulent atmosphere. Our atmosphere is not a calm, uniform medium. It is filled with pockets of warmer and cooler air, all moving around, what we call atmospheric turbulence. As the star's single thin beam of light passes through these turbulent pockets of air, it gets bounced around and refracted or bent in different directions. This constant, rapid bending of the light path is what our eyes perceive as twinkling. The star's brightness and its position seem to flicker and dance around. You can see the same effect on a hot day when you look at objects over a long stretch of hot pavement.
The heat rising from the pavement distorts the air, making the objects behind it seem to shimmer. This is also why planets, for the most part, don't twinkle. Planets are much, much closer to us. So while a star is a single point of light, a planet, when viewed through a telescope, is a small, visible disk. You can think of a planet's light as being like thousands of tiny points of light all coming from the same object. While each of these individual points of light is being twinkled by the atmosphere, our eyes average all of them out, and the planet appears as a steady, serene point of light in the sky. So twinkling is not a property of the stars, but a quiet testament to the lively, restless ocean of air that we live at the bottom of.
Now, let's leave the gentle misconceptions about stars and drift towards the most extreme and misunderstood objects in the cosmos. Let's talk about the myths surrounding black holes. The first and most pervasive of these is myth number 11, the idea that black holes are cosmic vacuum cleaners. This is a powerful image, one that science fiction has used for decades. We imagine a black hole as a hungry, roving monster, actively sucking in everything in its vicinity like a giant cosmic vacuum cleaner. We see spaceships getting pulled inexorably towards them from vast distances, but this is a fundamental misunderstanding of how their gravity works. The quiet truth is that a black hole's gravity is only extreme when you get very, very close to it. From a large distance, its gravity is exactly the same as any other object of the same mass. Let's imagine a thought experiment. If our sun were to magically and instantly be replaced by a black hole of the exact same mass, what would happen to the Earth and the other planets? The answer is absolutely nothing. The Earth would continue in its same stable orbit at the same speed around this new dark object. The sky would go dark and our planet would freeze, of course, but our orbit would be completely unchanged. We wouldn't be sucked in. The black hole would just sit there at the center of the solar system, exerting the exact same gravitational pull that the sun does now. You have to get very close to a black hole, within a few dozen kilometers, to enter the region where its gravity becomes truly exotic and inescapable. They are not cosmic vacuum cleaners. They are incredibly dense, but very passive gravitational objects. They don't hunt, they just wait. This leads us to our next myth about these strange objects. Myth number 12. This is the idea that it's impossible to orbit a black hole safely. Stemming from the cosmic vacuum cleaner idea, many people assume that getting anywhere near a black hole means you are doomed to fall in. But as we've just learned, a black hole's gravity is normal from a distance, so it is perfectly possible for a planet, a star, or a spacecraft to have a stable, safe orbit around a black hole, just as the Earth orbits the Sun. In fact, we have observed this directly. At the center of our own Milky Way galaxy, astronomers have spent decades tracking the orbits of a group of stars, known as the S-stars, as they whip around our central supermassive black hole, Sagittarius A*. These stars are in stable, if very fast and elliptical, orbits. Some of them get incredibly close to the black hole at their nearest approach, traveling at several percent of the speed of light before swinging back out again safely. Their stable orbits are the best evidence we have for the mass of the black hole at our galaxy center. So, you can orbit a black hole safely. However, this myth has a kernel of truth to it, which adds a layer of quiet complexity. While a stable orbit is possible, the environment near a supermassive black hole can be one of the most violent and dangerous places in the universe. If the black hole is active, that is, if it is actively feeding on a large amount of gas and dust, it will be surrounded by that huge, incredibly hot, and brilliantly bright accretion disk we've talked about before. This disk is a maelstrom of high-energy radiation, X-rays, and intense magnetic fields. Any planet or spacecraft orbiting within or near this disk would be sterilized and bombarded with deadly radiation.
So, while your orbit might be gravitationally stable, the neighborhood would be extremely hazardous to your health. A quiet, dormant black hole is a safe neighbor. An active, feeding one is not.
Our final black hole myth, myth number 13, is perhaps the most absolute and most famous statement made about them, that nothing can escape a black hole. This is, for all practical purposes, the very definition of a black hole. Its escape velocity is greater than the speed of light. So once you cross the event horizon, there is no getting out. And on any normal human timescale, this is absolutely true. But on the vast, almost eternal timescales of the cosmos, the quiet, strange laws of quantum mechanics introduce a loophole. As we've discussed in other stories, the great physicist Stephen Hawking in the 1970s showed that black holes are not completely black. They should, in fact, glow very, very faintly. This phenomenon, now known as Hawking radiation, is a consequence of quantum effects happening right at the edge of the event horizon. The idea, in a simplified nutshell, is that the vacuum of space is filled with virtual particle pairs that pop into and out of existence for fleeting moments. At the very edge of an event horizon, it's possible for one particle of a pair to fall into the black hole while the other escapes into space. To an outside observer, it looks as if the black hole has just emitted a particle. Because energy can't be created from nothing, the energy for this escaping particle is stolen from the black hole's own mass. This means that a black hole is not a one-way street forever. It is, in fact, slowly evaporating. The process is so incredibly, unimaginably slow for a large black hole that it's almost meaningless on human scale. A black hole with the mass of our Sun would take longer than the current age of the universe to evaporate, by a factor of trillions upon trillions. But it does mean that, eventually, over an almost infinite amount of time, a black hole will radiate itself away until it completely disappears. So in the longest run imaginable, things can escape a black hole in the form of this gentle, quiet, and incredibly slow thermal hiss.
Let's now zoom our perspective all the way out and tackle a couple of quiet misconceptions about the grandest scales of all, time and distance in the cosmos. First, myth number 14, a simple but very common point of confusion. It's the idea that a light year is a measure of time. It's an understandable mistake. The word year is right there in the name, so our brains naturally want to associate it with a duration. But a light year has nothing to do with time. It is a measure of distance. It is the distance that a beam of light, the fastest thing in the universe, can travel in one full Earth year. Let's just quietly appreciate how vast that distance is. Light travels at an incredible 300,000 kilometers per second. That means in 1 second, a beam of light could circle the Earth more than 7 times. So in 1 full year, that beam of light travels about 9.5 trillion kilometers, or about 6 trillion miles. That colossal distance is a single light year. When we say the Andromeda Galaxy is 2.5 million light years away, it means that the light we see from it tonight has been traveling for 2.5 million years to reach us. So while it is a measure of distance, it is also, in a beautiful way, a time machine. It allows us to see objects as they were in the distant past. The light year is the fundamental yardstick we use to measure the immense, quiet emptiness between the stars. Our 15th myth is a more abstract one about the nature of the universe's expansion. This is the idea that the universe is expanding into something. It's a very natural mental picture to have. We think of the Big Bang as an explosion, and we imagine a ball of galaxies expanding outwards from a central point into a pre-existing empty black void. But this picture, as intuitive as it is incorrect.
The quiet truth is that the universe is not expanding into anything. The universe itself is expanding.
This is a very difficult concept to visualize, but let's try a gentle analogy. Imagine you have a loaf of raisin bread dough before you put it in the oven. Now imagine you're a tiny ant living on one of the raisins. From your perspective, you can see all the other raisins nearby. Now, you put the bread in the oven, and it begins to rise. The dough itself expands. As the dough expands, you would notice a strange thing. Every single other raisin would be moving away from you. And the farther away a raisin is, the faster it would seem to be moving away from you because there is more expanding dough between you and it. This is exactly what we see with the galaxies in our universe. It's not that the galaxies are flying through space away from a central explosion point. It's that the fabric of space itself, the dough of the universe, is stretching and expanding everywhere at once, carrying the galaxies along with it. In this analogy, there is no center to the expansion. Every raisin would see all the other raisins moving away from it, and there is no edge to the bread dough that it is expanding into. The expansion is happening everywhere within the dough itself. This is our best understanding of the cosmic expansion. It is a quiet, uniform stretching of the fabric of space-time itself. It is a profound and beautiful idea that challenges our everyday common-sense view of the world. The universe is not an explosion in an empty room. The universe is the room, and the room itself is getting bigger. And with that vast thought, let's bring our focus back to our own species and our own stories about space. It is here that we find some of the most persistent and fascinating myths of all. In this final, deep section of our journey, we will explore the myths that are closest to home. These are the stories we tell about our own attempts to reach for the stars, and about our deep-seated hopes and fears regarding who or what might be out there waiting for us. These are the stories of conspiracy and the stories of science fiction, and untangling them is a quiet and fascinating process. We must begin with the biggest, most enduring, and most complex of all space myths. This is myth number 16, the idea that the moon landing was faked. This is perhaps the mother of all modern conspiracy theories. The idea is that in the late 1960s and early 70s, at the height of the Cold War and the space race, NASA did not have the technology to safely send astronauts to the moon and bring them back. So to win the race against the Soviet Union and fulfill President Kennedy's promise, they faked the whole thing. The theory goes that the moonwalks were secretly filmed on a movie set, perhaps in the Nevada desert, and that the entire Apollo program was a colossal deception. Over the decades, proponents of this theory have pointed to what they see as proof in the photos and videos from the missions. They ask questions that, on the surface, can seem quite compelling. Why is the American flag waving if there's no wind on the moon? Why are there no stars in the sky in any of the pictures? Why do the shadows seem to go in different directions, as if there were multiple light sources, like on a movie set? Tonight, we are going to look at these questions one by one, not to ridicule them, but to treat them as genuine puzzles and to find the quiet, simple, scientific answers. And what we'll find is that the evidence for the reality of the moon landing is, in its own way, just as fascinating as the conspiracy theory itself.
Let's start with the most famous piece of supposed evidence, the waving American flag. In the footage from the Apollo 11 moonwalk, The flag does indeed appear to ripple and wave as Neil Armstrong and Buzz Aldrin plant it in the lunar soil. If there is no air on the moon to create wind, how can the flag be waving? The answer is a quiet and elegant piece of engineering and physics. The NASA engineers knew that a normal flag would just hang limply in the airless environment of the moon, which wouldn't make for a very inspiring photograph. So, they designed the flag assembly with a horizontal telescoping rod that extended out from the top of the main vertical pole to hold the top edge of the flag out. It's essentially a celestial curtain rod. However, on the Apollo 11 mission, the astronauts had some trouble extending this telescoping rod all the way. It only extended partway, which caused the nylon flag to be bunched up and wrinkled. These wrinkles give it the appearance of being caught in a breeze. And the waving motion? That's simple momentum. Imagine trying to stick a pole into hard, resistant ground. You have to twist and turn it with a lot of force. That is exactly what the astronauts were doing. All of that twisting motion was transferred to the flexible flag, causing it to ripple and wave back and forth. And here is the beautiful part that actually proves it's in a vacuum. On Earth, the friction from the air would quickly dampen that motion and cause the flag to stop waving. But on the moon, with no air resistance to slow it down, the flag continued to ripple and sway for quite some time, just as you would expect an object in a vacuum to do. So the very thing that is pointed to as proof of a hoax is actually perfect evidence of the real lunar environment.
Now for the next great visual puzzle, the question of the stars. In every single photograph taken on the surface of the moon, the lunar sky is a deep, profound jet black. There are no visible stars. This has led many to claim that this must be a fake studio backdrop. After all, with no atmosphere to obscure the view, the stars should be incredibly bright and clear, right? This is a very intuitive argument, but it's based on a misunderstanding of how a camera works. The answer to this mystery is all about exposure. Let's imagine a simple scenario on Earth. You are standing outside at night next to a brightly lit campfire. Your friend takes a picture of you. In that picture, your face, illuminated by the fire, will be perfectly exposed. But the dark forest behind you and the faint stars in the sky above will be completely black. Why? Because to get a good picture of your brightly lit face, the camera's shutter speed has to be very fast and its aperture has to be very small. It's only letting in a tiny amount of light. This is enough to capture the bright fire, but it's not nearly enough to capture the faint, distant light of the stars. The exact same thing was happening on the moon. The lunar surface during the daytime is a brilliantly lit environment. The ground is being hit by direct, unfiltered sunlight. The astronauts in their bright white spacesuits were also incredibly bright. The photographers, the astronauts themselves, had to set their cameras with a very fast shutter speed and a very small aperture to get a proper exposure of the brightly lit landscape and their crewmates. These camera settings were, just like with the campfire, far too fast and dark to ever pick up the relatively faint light of the distant stars. If they had wanted to take a picture of the stars, they would have had to use a very long exposure, which would have completely washed out the entire lunar landscape and the astronauts into a single overexposed white blur. The lack of stars is not a sign of a fake backdrop. It's the sign of a real photograph being taken in a very bright environment.
The third major piece of supposed evidence from the photographs is the nature of the shadows. Critics point out that on the moon, where the sun should be the only light source, all shadows should be perfectly parallel to each other. But in some of the Apollo photos, shadows from different objects seem to go in slightly different directions.
This, they claim, proves that multiple light sources were used, just like on a movie set with studio lighting. This is another puzzle that seems compelling on the surface, but has a very simple and elegant explanation. Perspective. The lunar surface is not a flat, perfect studio floor. It is a bumpy, uneven, and undulating landscape, filled with small craters, hills, and dips. When you project shadows onto an uneven surface, they will appear to be non-parallel, even if the light source is a single distant point. It's a trick of perspective. You can see the same effect right here on Earth on a sunny day. The shadows cast by telephone poles on a hilly street will not look perfectly parallel to each other. Another claim is that the shadows on the moon are not completely black. You can still see details on the side of an astronaut or the lunar module that should be in deep shadow. This, they say, also proves that extra fill lights were used to illuminate the scene. But this too has a beautiful explanation. While the sun was the primary light source, there was another massive light source on the moon, the ground itself. The bright gray lunar soil is actually quite reflective. It was lit up by the sun, and it acted like a giant, natural reflector card, bouncing soft, gentle light back up into the shadows, allowing us to see those details. The astronauts were being illuminated by both the direct, harsh light of the sun from above and the soft, reflected light of the moon from below. Again, the visual strangeness is actually perfect evidence of the real lunar environment.
One of the more scientific-sounding claims made by those who doubt the moon landings concerns the Van Allen radiation belts. These are two donut-shaped zones of intense, trapped radiation that surround the Earth, held in place by our planet's magnetic field. The claim is that the radiation in these belts is so lethal that the Apollo astronauts could not have possibly survived the journey through them. This is a great example of a myth that takes a real scientific fact, the existence of dangerous radiation belts, and then misinterprets the level of the threat. The Van Allen belts are indeed dangerous, and prolonged exposure would be fatal, but the key is the duration of the exposure. The Apollo missions were not designed to linger in the belts. The trajectory of the spacecraft was carefully planned to pass through the belts at their thinnest points and to do so very, very quickly. The Apollo spacecraft were traveling at incredible speeds on their way to the moon. They passed through the most intense parts of the Van Allen belts in less than an hour. Furthermore, the astronauts were not in their thin spacesuits. They were inside the command module, which was a tough, resilient spacecraft. The metal hull of the capsule itself provided a significant amount of shielding against the radiation particles. So while the astronauts did receive a dose of radiation during their passage through the belts, the dose was very small and well within the safe limits established by NASA for the mission. Their total radiation dose for the entire multi-day mission to the moon and back was, on average, less than what some workers in the nuclear industry might receive in a year on Earth. The Van Allen belts are a real hazard, but they were a well-understood and manageable one for the Apollo missions.
So, we've gently unpacked some of the most common claims of the moon landing hoax theory. But what about the definitive, positive proof that we did go? While there are countless pieces of evidence, let's just focus on two quiet, simple, and completely undeniable facts. The first is something we talked about in another story. It is the laser-ranging retroreflector. On the Apollo 11, 14, and 15 missions, the astronauts placed special mirror arrays on the lunar surface. These are not normal mirrors. They are sophisticated arrays of corner cube reflectors, designed to reflect a laser beam directly back to the point it came from with incredible precision. And to this day, right now, observatories on Earth, like the McDonald Observatory in Texas, routinely aim powerful laser beams at these reflectors.
They then use incredibly sensitive detectors to catch the few photons that make the 800,000-kilometer round trip. By precisely timing how long this journey takes, they can measure the distance to the moon with an accuracy of a few millimeters. This experiment has provided a wealth of scientific data, proving, for example, that the moon is slowly drifting away from the Earth. And it is an experiment that would be completely impossible if those reflectors were not sitting on the lunar surface, right where the Apollo astronauts left them. The second piece of undeniable proof is the rocks. Over the course of the 6 Apollo landings, astronauts brought back a total of 382 kilograms, or 842 pounds, of lunar rocks, core samples, and soil. These rocks are not like any rocks on Earth. They are completely devoid of water. They show evidence of having been formed in a low-gravity, no-atmosphere environment. And they have been exposed to billions of years of cosmic ray bombardment on their surface. They are unmistakably from the moon. These rocks have been shared with and studied by thousands of independent scientists in laboratories all over the world for the past 50 years. To believe in a moon landing hoax is to believe that all of those thousands of scientists from dozens of different countries have all been part of a massive 50-year-long conspiracy without a single one ever breaking their silence.
The quiet, simple truth is that we went. The achievement was real, and it was, in many ways, even more difficult and more incredible than we often remember. Now let's leave the myths of our own space program behind and turn our attention to the other side of the space race and the ghostly, persistent myths that grew out of the intense secrecy of the Soviet program. This is myth number 17, the story of the lost cosmonauts. As we explored in our story about Yuri Gagarin, this is the powerful conspiracy theory that claims Gagarin was not the first man in space, but merely the first to survive the journey. The theory posits that the Soviet Union secretly launched a number of other cosmonauts before Gagarin, but that their missions ended in disaster, their deaths covered up by a ruthless state obsessed with projecting an image of perfection. The primary evidence for this theory comes from the work of 2 young Italian amateur radio operators in the early 1960s, the Giudica Cordiglia brothers. From their homemade listening post in Turin, they claimed to have intercepted a series of tragic radio transmissions from these secret doomed flights. It's a compelling and chilling story. Let's quietly revisit some of their most famous alleged recordings. One of the first was a recording they made in November of 1960, which they claimed captured a faint SOS signal in Morse code coming from a spacecraft that was drifting away from the Earth, lost in space. A few months later, in February 1961, they released a recording that they said captured the sound of a lone cosmonaut's failing heartbeat, broadcasting from orbit until it finally went silent. But the most famous and most haunting recording was released in May of 1961, just after Gagarin's successful flight. It purports to be the voice of a female cosmonaut. In the recording, a panicked woman's voice is heard, speaking in Russian, her words becoming more distressed as she seemingly burns up during a failed re-entry into the atmosphere. These tapes paint a grim picture of the Soviet space program, a story of secret sacrifice and hidden failures.
So what is the quiet truth behind these ghostly recordings? As we've discussed, while the Giudica Cordiglia brothers were almost certainly picking up real signals from real Soviet space missions, the mainstream historical and technical consensus is that they were misinterpreting what they were hearing. The Soviet space program was indeed full of failures, but these were failures of unmanned test flights, not secret crewed missions.
Let's look at the famous recording of the woman burning up. When linguistic experts and native Russian speakers have analyzed the tape, they have pointed out numerous problems. The grammar is often incorrect, the sentence structure is awkward, and the speaker uses some non-standard phrases. It sounds less like a native speaker in a moment of distress, and more like someone reading from a script with an accent. Furthermore, the technical data on the recording does not match what you would expect from a re-entering capsule. It's far more likely that the brothers were listening to a ground-based training exercise or a pre-recorded test transmission being broadcast from an orbiting satellite to check the communication links. The same goes for the other recordings. The fading heartbeat signal, for example, is a very close match for the known telemetry signals from the Korabel Sputnik flights that were carrying dogs into orbit, broadcasting the animal's vital signs back to Earth. The story of the lost cosmonauts is not really a story about dead spacemen. It's a story about the power of secrecy. The Soviet Union's absolute refusal to be open about its program, to admit its failures, created a void of information. And in that void, the imaginations of two young men in Italy, combined with the paranoia of the Cold War, created a powerful and enduring modern myth. The whispers they heard in the static were real, but the tragic stories they told were likely their own creation.
Now let's leave the world of conspiracy and history behind and move to our final section of myths. These are the quiet misconceptions that have been born from the wonderful world of science fiction. Sci-fi movies and books have done more to inspire a love of space than almost anything else. But they also, for the sake of good drama, often have to bend or break the laws of physics. Let's gently explore a few of the most common tropes. We begin with myth number 18, the myth of sound in space. It's one of the most iconic sounds in all of cinema. A giant spaceship glides by with a deep rumbling roar. A laser blast makes a satisfying pew-pew sound. A massive explosion from a Death Star creates a huge booming kaboom. These sounds are dramatic, exciting, and an essential part of the cinematic experience. And they are all completely impossible. The quiet truth is that space is almost perfectly silent. Sound, as we experience it, is a pressure wave. It is a vibration that travels through a medium, like air or water. Our eardrums vibrate when these pressure waves hit them, and our brains interpret that vibration as sound. The vacuum of space, however, is not a medium. It is, for all practical purposes, empty. There are no molecules to vibrate, no medium to carry a pressure wave. So if you were floating in space next to a giant exploding starship, you would see a brilliant flash of light, but you would hear absolutely nothing. It would be a completely silent, deeply unsettling spectacle. The silence of space is one of its most fundamental and most alien characteristics. The only sounds an astronaut ever hears are the sounds created inside their own helmet and their own ship. The sound of their own breathing, the crackle of their radio, and the constant gentle hum of the life support machinery that is keeping them alive in that vast, quiet emptiness.
Our 19th myth is the one that makes almost all of our favorite space operas possible. It's the idea of instantaneous interstellar travel. In movies, traveling between star systems is often as simple as a short journey. A spaceship engages its hyperdrive or its warp drive. The stars stretch into long streaks of light, and a few moments later, they arrive in a completely different part of the galaxy. It's a wonderful and necessary narrative shortcut that allows for grand galaxy-spanning stories. But the quiet and rather inconvenient truth is the tyranny of immense distance. As we've discussed, the stars are incredibly, almost incomprehensibly far apart. Our nearest neighboring star system, Alpha Centauri, is over 4 light-years away. That means even if we could travel at the speed of light, the ultimate speed limit of the universe, it would still take us over 4 years to get there. With our current technology, like the Parker Solar Probe, which is the fastest object ever built by humans, the journey would take thousands of years. The distances are simply too vast for casual travel. Now, what about those sci-fi concepts like warp drive? The idea of a warp drive, first popularized by Star Trek, is based on a real, though highly speculative, concept in general relativity called the Alcubierre drive. The idea is to not travel through space, but to warp the fabric of space itself, compressing space in front of your ship and expanding it behind you, creating a warp bubble that could theoretically travel faster than light. The problem is that creating such a bubble would require a form of exotic matter with negative mass and negative energy, something we have never observed and which may not be physically possible. So for now, and for the foreseeable future, instantaneous interstellar travel remains firmly in the realm of fiction. The galaxy is a quiet, vast, and very, very distant place.
Our final myth tonight, myth number 20, is perhaps the most deeply ingrained of all our science fiction assumptions. It is the myth of the humanoid alien. When we imagine intelligent life from another world, we almost always imagine something that looks, at least vaguely, like us. They might have green skin, or pointy ears, or an extra set of arms, but they almost always have 2 arms, 2 legs, a torso, a head and a face with 2 eyes, a nose, and mouth. They are essentially just slightly modified humans. There is a scientific argument for why this might be the case, a concept called convergent evolution. This is the idea that different species in similar environments will often independently evolve similar features to solve similar problems. For example, wings have evolved independently in insects, birds, and bats because it's a very effective solution to the problem of flying through the air. So one could argue that a bipedal, 2-armed form with sensory organs clustered on a head is a very efficient body plan for a tool-using, intelligent species on a planet with gravity. But this is a very Earth-centric view. The range of possible environments for life in the universe is immense. Why should we assume that life on a low-gravity water world or a high-gravity gas giant would evolve in the same way? The honest truth is that there is absolutely no scientific reason to assume that intelligent life on another world would look anything at all like us. It could be completely, unimaginably different. It could be a colony of intelligent insects. It could be a sentient planet-spanning fungus. It could be a form of life based not on carbon, but on silicon. It could be a gaseous being that lives in the clouds of a gas giant. Or, as we've discussed, it could have long since abandoned its biological form and exist as pure machine intelligence. The quiet and perhaps slightly unsettling truth is that if we ever do meet life from another world, we might not even recognize it as life at all.
And so, our long and quiet journey through the whispers and truths of space comes to an end. We have wandered through the myths of our own solar system, discovering that the asteroid belt is a lonely wilderness and that the dark side of the moon is not dark at all. We have looked at the stars and learned that their twinkling is just a trick of our own atmosphere, and that the sun's true color is a brilliant, pure white.
we have explored the strange physics of black holes, realizing they are not cosmic vacuum cleaners, but passive, quiet giants. And finally, we have looked at the stories we tell about ourselves, gently unpacking the enduring myths of the moon landing and the lost cosmonauts, and contrasting them with the imaginative but physically impossible tropes of our favorite science fiction. I hope this quiet exploration has been a comforting one. The reason we have these myths, I think, is because the universe is a very big and often counterintuitive place. Our human brains evolved to understand the world on a human scale, the speed of a running animal, the weight of a heavy stone. The scales of the cosmos, the immense distances, the vast timescales, the extreme physics are things our intuition is not built to handle. So we tell simpler, more dramatic, more relatable stories to try and make sense of it all. But the wonderful thing about science is that it allows us to slowly, patiently, and quietly peel back those stories and glimpse the reality that lies beneath. And that reality, I find, is almost always more beautiful, more complex, and more deeply awe-inspiring than any myth we could create.
Let's drift back just for a moment and spend more time with the quiet truth behind the Kessler syndrome, which we touched upon in another story. This idea, myth number 21, is that space is so big, our debris doesn't matter. It's easy to think that the vastness of space can absorb our messes, that the small amount of junk we leave in orbit is insignificant. But the problem isn't the volume of space, it's the concentration of activity in very specific, very useful orbits. Low Earth orbit, or LEO, the region up to about 2,000 kilometers in altitude, is the most valuable piece of real estate in space. It's where the International Space Station lives. It's where most of our weather, imaging, and communication satellites are, including the new mega constellations like Starlink. It's a very busy highway. And on this highway, everyone is traveling at about 28,000 kilometers per hour. A collision at that speed is not a fender bender, it's a hypervelocity explosion. When two 1-kilogram satellites collide head-on, the energy released is equivalent to detonating about 40 kilograms of TNT. Such a collision would create a cloud of thousands of new, smaller pieces of shrapnel, each one now its own tiny, deadly projectile. This is the heart of the Kessler syndrome. It's a chain reaction. Each collision creates more debris, which increases the probability of more collisions, which creates even more debris. The terror of this isn't a sudden dramatic event, it's a quiet, statistical tipping point. It's the fear that we could slowly and then very quickly pollute these vital orbital highways to the point where they become unusable for generations. It's a form of slow-motion, self-imposed exile, trapping ourselves on our own planet beneath a glittering, dangerous shell of our own making. It's a quiet but urgent reminder that we must be as good at cleaning up after ourselves as we are at launching new things into the sky.
Now, let's explore another subtle myth about black holes. Myth number 22, that a black hole is a portal or a wormhole to another place or time. This is one of the most beloved and enduring tropes in all of science fiction. A black hole isn't just a point of destruction, it's a gateway. Our heroes fly their ship into the swirling vortex, pass through a psychedelic tunnel of light, and emerge in another galaxy or another dimension. It's a wonderful and convenient storytelling device. But sadly,
according to our current understanding of physics, it's a complete myth. A black hole, as described by Einstein's general relativity, is a one-way street to a single destination, the singularity at its center. It is not a tunnel. The theory describes the singularity as a point of infinite density where the known laws of physics cease to exist. It is the end of space-time itself. Anything that crosses the event horizon is on an irreversible journey to be crushed out of existence at this central point. There is no other side. Now, it's true that some very speculative, theoretical solutions to Einstein's equations do allow for the possibility of things like wormholes, which could, in theory, connect to different points in space-time. But these are not the same as the black holes that are formed from collapsing stars. A traversable wormhole, if one could even exist, would require exotic forms of matter with negative energy to keep it open, something we have never observed. So while it's a beautiful and romantic idea, a black hole is not a doorway. It is a final destination. The quiet truth of a black hole is, in a way, much more profound and final than the fiction. It is a place where space and time themselves come to an end, a true point of no return. It's a quiet, humbling reminder of the ultimate power of gravity.
Let's turn now to a myth about the very beginning. Myth number 23, that the Big Bang was an explosion in space. When we hear the word bang, we naturally picture an explosion, like a bomb going off at a single point in an empty room with shrapnel flying outwards into the surrounding space. We tend to imagine the Big Bang in the same way, a single point of energy that exploded in the middle of a pre-existing empty black void. But this mental picture, as common as it is fundamentally incorrect. The Big Bang was not an explosion in space, it was the explosion of space itself. Before the Big Bang, there was no space, no time, no emptiness for it to expand into. The Big Bang happened everywhere at once. Let's go back to our raisin bread analogy. The Big Bang is the moment the entire loaf of dough begins to rise. A single raisin inside the dough wouldn't see the explosion happening over there. It would experience the expansion happening everywhere around it, in all directions. The space between it and all the other raisins would simply be stretching. This is a crucial distinction. It means that there is no center of the universe, no single point from which everything is expanding away. Every point in the universe can be considered the center. An observer in a galaxy a billion light years away would see all the other galaxies moving away from them, just as we do. It also means there is no edge of the universe that is expanding into a void. The universe is not a sphere of matter expanding into nothingness. It is the fabric of space-time itself in its entirety, getting bigger. It's a quiet, deeply counterintuitive, but beautiful idea. It means we are not just in the universe, we are the expanding universe.
Our next myth is a quiet, visual one about stars. Myth number 24, that stars are shaped like a star with pointy tips. When we are children and we draw a star, we draw a shape with 5 or 6 sharp points. And even in many scientific diagrams, stars are often depicted with these radiating points of light. This is so deeply ingrained in our culture that we often think this is what stars actually look like up close. But of course, stars are not pointy. They are spheres. They are colossal, nearly perfect balls of hot plasma, held together by their own immense gravity. The reason they appear pointy to us is because of a trick of our own eyes. When a bright, concentrated point of light enters the lens of our eye, some of that light gets diffracted or scattered by the tiny, microscopic imperfections and structures within the eye itself, particularly the suture lines on our lens. This scattering of light creates the familiar star-like pattern of spikes and rays that we perceive. You can see this effect with any bright point of light at night, not just a star. A distant street lamp will also appear to have these same star-like rays. The pattern is unique to your own eye. My star pattern is slightly different from yours. So the beautiful, sharp, twinkling points of a star that we see in the night sky are not a property of the star itself. They are a quiet, personal, and beautiful artifact of our own human biology, a fingerprint of our own eye imposed upon the cosmos. And for myth number 25, a myth about sound. We've established that space is silent. But what about the sun? It's a giant, churning nuclear explosion. Surely it must be incredibly loud, right? The myth is that the sun is silent. The truth is much more interesting. The sun is, in fact, deafeningly, unimaginably loud.
The surface of the sun is a turbulent ocean of superheated plasma, with convection cells the size of countries constantly rising and falling. This churning motion creates immense sound waves, just like a pot of boiling water, but on a colossal scale. The amount of sound energy produced by the sun is staggering. If you could somehow float near the sun and be protected from its heat and radiation, the roar would be absolutely overwhelming. It's estimated that the sound level would be over 100 decibels, even from 150 million kilometers away here at Earth. That's as loud as a rock concert or a jet engine taking off. So why don't we hear it? Because, as we established, space is a near-perfect vacuum. Sound waves need a medium to travel through. They need molecules to vibrate. The vast emptiness between the sun and the Earth provides no medium for its colossal roar to travel across. So the sun's incredible sound is trapped, unable to ever reach us. We live our lives in the silent zone of a deafeningly loud star. I find this to be a wonderfully poetic and calming idea. It's a testament to the quiet, insulating nature of the void. The universe is filled with incredible violence and unimaginable noise, but the emptiness of space acts as a perfect, gentle buffer, protecting our quiet little world from the true fury of the cosmos. The silence of space is not a sign of emptiness, but a sign of insulation. It is a quiet gift from the vacuum itself. Now, for myth number 26, let's turn to gravity. It's the idea that there is zero gravity in space. We see astronauts floating on the space station, and we say they are in 0G. But this isn't really true. The force of gravity on the International Space Station is almost as strong as it is on the surface of the Earth.
The ISS orbits at an altitude of about 400 kilometers. At that height, the Earth's gravitational pull is still about 90% as strong as it is down here on the ground. If the space station were to just stop moving, it would immediately fall straight back down to Earth. So why are the astronauts floating? The reason is that they are in a constant state of free fall. This is the same feeling you get at the very top of a roller coaster's hill, just as you start to go down, or for a few brief seconds on a Vomit Comet airplane. The space station and everything inside it is constantly falling towards the Earth, but it is also moving sideways at an incredible speed, about 28,000 kilometers per hour. It is moving so fast horizontally that as it falls, the curve of the Earth is constantly falling away beneath it. So it is falling, but it never hits the ground. It is perpetually missing the Earth. This state of constantly falling around the Earth is what we call an orbit. And it's this free fall that creates the sensation of weightlessness. The astronaut, the station, and the camera filming them are all falling together at the exact same rate, so relative to the station, the astronaut appears to float. A much more accurate term for what they are experiencing is not zero gravity, but microgravity. It's a quiet, beautiful, and deeply counterintuitive piece of orbital mechanics. Floating isn't the absence of gravity, it's the result of giving into it completely. And now for myth number 27, a quiet misconception about orbits themselves. We are used to seeing diagrams of the solar system with neat circular orbits for all the planets. But the truth is, no planet in our solar system has a perfectly circular orbit. Every single orbit, from Mercury to Neptune, is a slight ellipse.
An ellipse is just a slightly squashed circle with two focal points instead of one center. A star, like our Sun, sits at one of these focal points. This means that for every planet, there is a point in its orbit where it is closest to the Sun, its perihelion, and a point where it is farthest away, its aphelion. For most of the planets, like Earth and Venus, these ellipses are so close to being perfect circles that you would never notice the difference just by looking. Earth, for example, is about 147 million kilometers from the Sun at its closest, and about 152 million kilometers at its farthest. It's a small difference, and it's actually not the primary reason we have seasons. The seasons are caused by the tilt of our planet's axis. But for some other objects, the elliptical nature of their orbits is much more dramatic. The dwarf planet Pluto, for example, has a very eccentric orbit. It is so elliptical that for about 20 years of its 248-year journey, it actually comes closer to the Sun than the planet Neptune does. So for a brief period in its history, Pluto is actually the 8th planet from the Sun, and Neptune is the 9th. Comets have the most extreme elliptical orbits of all. They spend hundreds or thousands of years in the cold, distant outer solar system, and then they swing in for a brief fiery pass close to the Sun before heading back out again. This quiet, simple fact that all orbits are ellipses was the first great discovery of the astronomer Johannes Kepler in the 17th century, and it was the key that unlocked our modern understanding of how the planets move. The solar system is not a perfect clockwork of circles, but a beautiful, complex dance of ellipses.
Let's now return to the human element for our final set of myths. This is myth number 28, a quiet but important one about the history of space exploration. The idea that NASA's space shuttle was the first reusable spacecraft. The space shuttle is an icon. Its ability to launch like a rocket, operate in orbit like a spacecraft, and then land on a runway like a plane was a monumental achievement. And because it was reusable, many people assume it was the very first spacecraft to achieve this feat. But the quiet truth is that the concept and even the reality of a reusable spaceplane existed before the shuttle. In the 1960s, the U.S. Air Force had a top-secret program called the X-20 Dinosaur. It was a small winged spaceplane designed to be launched on a rocket, conduct military reconnaissance from orbit, and then land on a runway like a plane. It was a very advanced program, and a test pilot, Neil Armstrong, was even selected to be one of its first astronauts before he transferred to NASA. The program was ultimately canceled in 1963 before it ever flew, but the idea was there. More concretely, the Soviet Union also had a space shuttle program. In the 1980s, they developed a reusable orbiter called the Buran. It looked remarkably similar to the American shuttle, but it had some key differences. Its main engines were on its giant booster rocket, not on the orbiter itself. The Buran orbiter made one single, uncrewed, but completely successful robotic flight to orbit and back in 1988. It landed perfectly on a runway, completely automated. Unfortunately, the program was canceled due to lack of funding after the collapse of the Soviet Union.
So while the American space shuttle had a long and storied career, the dream of a reusable spaceplane is one that was shared and even briefly realized by others.
Our next myth, myth number 29, is another from the world of science fiction that has become ingrained in our perception of space. It's the idea that lasers in space are visible beams of light. We see it all the time. A spaceship fires its laser cannons and we see brilliant red or green beams streaking across the screen. It's dramatic and visually satisfying. But in the vacuum of space, a laser beam would be completely invisible from the side. A beam of light is only visible to an observer if the light from that beam enters their eye. On Earth, we can see laser beams because the light is scattered by particles in the air, like dust, smoke, or water vapor. A small portion of the light from the beam hits these particles and is scattered in all directions, including towards your eye, allowing you to see the path of the beam. In the near-perfect vacuum of space, there is almost nothing for the light to scatter off of. A laser beam would be a perfectly straight, completely invisible line of energy traveling from its source to its target. You would only see two things: the point where the laser was fired, and the brilliant flash of impact where it hit its target. The space in between would be completely dark. A real space battle would be a strange, silent, and invisible affair, a series of brief, intense flashes of light in the darkness, not a colorful light show. Now for myth number 30, a quiet and rather funny misconception about astronaut training. The idea that NASA spent millions developing a pen that could write in space, while the Soviets just used a pencil. This is a very famous story, often used as a parable about over-engineering versus simple practical solutions. And it is, almost entirely, a myth.
The truth is that in the early days, both American astronauts and Soviet cosmonauts used pencils. But pencils were a problem. The tips can flake off, creating conductive graphite dust that could float into electronics. And the wood itself is flammable, a major concern in a pure oxygen environment like the early Apollo capsule. So both sides were looking for a better solution. The famous space pen was not actually developed by NASA. It was developed independently by a private inventor named Paul Fisher and his Fisher Pen Company. He spent over $1 million of his own money to create a pen with a pressurized ink cartridge that could write upside down, underwater, in extreme temperatures, and yes, in zero gravity. After developing it, he offered it to NASA. NASA tested it rigorously, and finding that it worked perfectly and was safer than pencils, they purchased a batch of them for the Apollo missions. And what about the Soviets? They also recognized the dangers of using pencils in space, and when they saw the success of the Fisher Space Pen, they simply did the same thing. They also purchased a batch of the same pens for their cosmonauts to use on their Soyuz missions. So the story is not one of a clumsy, over-engineered American solution versus a simple, clever Soviet one. It's a quiet story of a private inventor creating a genuinely useful piece of technology that was then adopted by both sides of the space race. It's a small but wonderful example of practical innovation. Our 31st myth, myth number 31, is a philosophical one about alien life. It's the idea that mathematics is a universal language. We often assume that if we ever make contact with an intelligent alien civilization, we will be able to communicate with them through the pure, objective language of math and physics. The movie Contact is a perfect example of this idea.
The idea is that while our cultures and biologies might be completely different, the laws of physics are the same everywhere. The value of pi is the same in our galaxy as it is in Andromeda. So a signal based on prime numbers or fundamental physical constants should be instantly recognizable as intelligent and artificial.
And this is a beautiful and very compelling idea. But some philosophers and scientists have questioned this assumption. Is our way of doing mathematics truly universal? Or is it a product of our specific human way of thinking, our primate brains, and our evolutionary history? We perceive the world in 3 spatial dimensions and 1 dimension of time. A civilization that evolved in a different environment, or one that was a non-biological machine intelligence, might have a completely different sensory experience, and therefore a completely different mathematical framework. Their mathematics might not be based on the same axioms as ours. They might not even perceive the universe in terms of individual objects and discrete numbers. It's possible that our system of mathematics is just one local language, one particular way of describing the universe, and that other intelligences might have developed other, equally valid, but completely translatable mathematical languages. The quiet, unsettling possibility is that even if we do hear a signal from another civilization, we might not even recognize it as a language at all. It might just sound like noise to us, and our own attempts at a universal hello might be equally incomprehensible to them.
Now for our final set of myths, we would look at some of the most common and enduring misconceptions about the very history of astronomy itself. Let's start with myth number 32, the idea that Christopher Columbus was trying to prove the Earth was round. This is a story taught in many schools. The idea is that in the 15th century, most people believed in a flat Earth, and Columbus was a brave, forward-thinking explorer who sailed west to prove them wrong. The quiet truth is that almost every educated person in 1492 knew that the Earth was a sphere. The ancient Greeks had proven it over 1,000 years earlier. They had observed the curved shadow of the Earth on the moon during a lunar eclipse, and they had noticed that ships disappeared over the horizon hull first. The debate that Columbus was having with the scholars of his day was not about the shape of the Earth, it was about its size. The accepted circumference of the Earth at the time, based on the ancient calculations of Eratosthenes, was actually remarkably accurate. Columbus, however, argued that the Earth was much smaller than everyone thought. He believed that Asia was much closer to Europe than it actually was, and that a westward voyage was therefore feasible. The scholars he was arguing with were right. He was wrong. His calculations were off by a huge margin. The only reason his voyage didn't end in disaster was because he accidentally and unexpectedly ran into an entire continent that no one in Europe knew was there. He was not a brilliant scientist proving a point. He was a bold navigator who made a colossal miscalculation and got incredibly lucky. And for our final historical myth, myth number 33, the idea that Galileo was condemned for arguing that the Earth orbits the Sun. This is another powerful story of a lone scientific hero fighting against religious dogma. And while Galileo was indeed tried by the Inquisition and spent the last years of his life under house arrest, the story is a bit more complex.
The story is often framed as a simple conflict between science and religion, but the reality was much more a matter of politics, personality, and timing. The Catholic Church in the 17th century was not uniformly anti-science. It ran many of its own observatories and employed many astronomer priests. The heliocentric model, the idea that the Earth orbits the Sun, had been proposed by Copernicus nearly a century earlier and was widely known and debated in academic circles without much issue. The initial problem was that at the time there was no definitive, direct proof that the Earth was moving. The observational evidence was still ambiguous. Galileo was a brilliant scientist, but he was also a proud, sarcastic, and often undiplomatic man. He was passionate and certain in his convictions, and he did not suffer fools gladly. His biggest mistake was not in his science, but in how he chose to present it. In his famous book, Dialogue Concerning the Two Chief World Systems, he presented the argument as a conversation between 3 characters. The character arguing for the sun-centered model was brilliant and witty. The character arguing for the earth-centered model, named Simplicio or Simpleton, was portrayed as a bumbling idiot. And Galileo put the exact words that his friend and supporter Pope Urban VIII had used in their private discussions into the mouth of this foolish character. This was seen as a direct, public insult to the Pope himself. The issue was no longer a quiet scientific debate. It had become a public challenge to the authority of the Church. Galileo was tried not just for his scientific beliefs, but for disobeying a previous church order not to advocate for the Copernican system as proven fact. His trial was a tragic and complex mix of science, politics, personality, and power. The quiet truth is that history is often much messier and more human than the simple stories we tell about it.
All right, we have explored the myths of our solar system, the cosmos, and our own human history. For this final section of our tour, let's look at a few myths that are a little more subtle. Myths that arise from the way our own brains perceive the universe around us. Let's call this the gallery of perception and scale. We begin with myth number 34, a beautiful and deeply personal illusion that almost everyone has experienced. This is the moon illusion. The illusion is this: when the full moon is rising and is low on the horizon, it appears absolutely enormous. It can look huge, swollen, and impossibly close, a giant pale orange lantern hanging just behind the distant trees or buildings. But as the night goes on and the same moon climbs higher into the sky, it appears to shrink, returning to its usual familiar size, a small silver coin in the vast darkness. But the moon's actual size and distance from us don't change in the course of a single night. So why does it look so much bigger on the horizon? This is a powerful optical illusion, and despite centuries of study, scientists are still not 100% certain what causes it. It is not a physical effect, it is a trick of our own minds. The leading theory is called the Ponzo illusion. Our brains are used to interpreting things on the horizon as being very far away. When we see the moon on the horizon next to familiar objects like trees and houses that we know are distant, our brain says, that object is very far away. It then sees the large image of the moon and thinks, wow, if it's that far away and still looks this big, it must be absolutely enormous. It scales the moon up in our perception. When the same moon is high in the sky, there is nothing to compare it to. It is just an object floating in an empty void. With no context for distance, our brain doesn't perform the same scaling trick, and we perceive it as being smaller. It's a quiet, beautiful, and still slightly mysterious illusion, a reminder that what we see is not always what is there. It is an interpretation, a story our own brain is telling itself.
Our next myth of perception, myth number 35, is a quiet and profound one about the nature of time. It's the intuitive belief that when we look at the stars, we are seeing them as they are now. We look up at the night sky and it feels immediate, like looking out a window at a landscape that exists in the present moment. But this is perhaps the grandest illusion of all. The universe is so vast that the speed of light, as fast as it is actually quite slow by comparison. This means that every single thing we see in the cosmos is, by necessity, a picture of the past. The farther away an object is, the longer its light has taken to reach us, and therefore the further back in time we are seeing it. The effect is small, but still real, even within our own solar system. The light from our moon is about 1.3 seconds old. The light from our sun is over 8 minutes old. When you look at Jupiter, you are seeing it as it was over half an hour ago.
But when we look to the stars, the effect becomes profound. The nearest star system, Alpha Centauri, is about 4.3 light-years away. When you see it in the sky, you are seeing it as it was 4.3 years ago. The light from Polaris, the North Star, has been traveling for over 400 years to reach your eye. You are seeing it as it was during the time of Galileo. And when we look at the Andromeda Galaxy, that faint, fuzzy smudge, you are seeing it as it was 2.5 million years ago, long before modern humans existed. Every telescope is a time machine. The act of looking out into space is always an act of looking back into the past. The deeper we look, the further back in time we see, all the way back to the cosmic microwave background, the baby picture of the universe itself. The present moment, a universal now, does not exist. There is only the light from countless different pasts, all arriving at your eye at the same time.
This leads us to our next quiet misconception, myth number 36, which is about our place in all of this. It's the idea that there must be a center of the universe. When we learn about the Big Bang, we intuitively picture it as an explosion happening at a single point in an empty space. So it seems logical that there must be a center, a ground zero from which everything is expanding away. But, as we discussed before, this is based on a misunderstanding of the expansion. The Big Bang was not an explosion in space. It was the expansion of space itself, happening everywhere at once. There is no center to the universe's space. But this is where the idea gets a little more subtle and interesting. While there is no center in space, there is a center in time. That center is the Big Bang itself, the moment that was the beginning for everything. And because of the finite speed of light, every observer in the universe has a unique relationship with that beginning. Because we can only see out to a distance of 13.8 billion light-years in any direction, we are, by definition, at the center of our own observable universe. An observer in a galaxy a billion light-years away from us would see themselves at the center of their own observable universe, and they would see our galaxy as being near the edge of their cosmic horizon. So, in a strange, democratic way, every point in the cosmos can be considered the center of its own observable bubble. It's a quiet philosophical idea that is both humbling, as it removes any special center from the cosmos, and also rather beautiful, as it places every observer at the very heart of their own perceived reality. The center of the universe, in a way, is wherever you are.
Our final myth of perception, myth number 37, takes us from the infinitely large to the infinitely small. It's the myth of solid matter. We live our lives in a world that feels solid. The chair you are sitting on, the floor beneath you, your own body, it all feels solid, dense, and real. But this feeling of solidity is perhaps the most powerful illusion of all. The quiet truth is that the atoms that make up everything you've ever touched are almost entirely empty space. Let's think about a single atom. It has a tiny, incredibly dense nucleus at its center, made of protons and neutrons. And then, orbiting this nucleus at a relatively vast distance, are its electrons. The popular model of an atom, the one we often see in diagrams, looks like a miniature solar system, with electrons orbiting a nucleus like planets. But a more accurate quantum mechanical picture is that of a probability cloud, a region of space where the electron is likely to be found. But the scale of this structure is what's truly mind-boggling. If you were to scale up the nucleus of a hydrogen atom to be the size of a marble, its single electron would be a fuzzy cloud over a kilometer, or more than half a mile away. The space in between is almost completely empty. The atoms that make up our world are 99.9999% empty space. So why do things feel solid? Why doesn't your hand just pass right through the table when you touch it? The feeling of solidness is not caused by matter bumping into matter. It is caused by the electromagnetic force. The electron clouds of the atoms in your hand are negatively charged, and they are powerfully repelling the negatively charged electron clouds of the atoms in the table. The sensation of touch is just the feeling of this immense electromagnetic repulsion. You have never truly touched anything in your entire life. You have only ever felt the force field of its atoms pushing back against the force field of yours. The solid world we experience is a quiet, powerful, electromagnetic illusion.
All right, for the last few exhibits in our quiet museum of myths, let's look at some final standalone misconceptions about the cosmos. We begin with myth number 38, the idea that black holes are funnel-shaped. This is an image we see everywhere. In textbooks, in documentaries, and in science fiction, a black hole is often represented as a 2D funnel on a flat grid, representing space-time. We see planets and stars spiraling down this cosmic whirlpool into the narrow point at the bottom. It's a very useful and intuitive way to visualize how a massive object warps the space around it. But it's important to remember that it is just a two-dimensional analogy for a four-dimensional reality. A real black hole is not a 2D funnel. It is a three-dimensional sphere. The event horizon, the point of no return, is a perfect spherical surface. If you were in a spaceship near a black hole, you wouldn't see a giant funnel in space. You would see a perfect circle of absolute blackness, a sphere that seems to absorb all light and reveal nothing. It would look like a hole has been punched out of the fabric of reality itself. The funnel analogy is just a way for our minds to try and visualize the concept of a gravity well. It shows how space-time gets more and more steeply curved as you get closer to the black hole. But the reality is much stranger. As you approach the event horizon, you are not falling down a funnel. You are in a region of space-time that is flowing inwards like a river from every single direction towards the central singularity. It's a quiet but important distinction that helps us move from the simple cartoon of a black hole to the much more profound reality.
Our next myth, myth number 39, is another one from science fiction. It's the idea that you can fly through a gas giant. We've all seen the scene. A spaceship is being chased, and to escape, the pilot makes a daring dive into the thick clouds of a Jupiter-like planet. They navigate through spectacular lightning storms and strange cloud canyons, eventually emerging out the other side. It's a thrilling sequence that treats the gas giant like a thick but ultimately traversable atmosphere. The quiet reality would be much less survivable. A gas giant like Jupiter has no solid surface to land on. That part is true, but it is not just a big ball of fluffy clouds. As you descend into its atmosphere, the pressure and temperature increase at a staggering rate. The outer layers are mostly hydrogen and helium gas, but as you go deeper, the immense pressure begins to compress the hydrogen gas so much that it transitions into a very strange state: liquid metallic hydrogen. This is not a gradual change. There is likely a distinct surface to this ocean of liquid metal, thousands of kilometers below the cloud tops. The pressure here is millions of times greater than on Earth, and the temperature is thousands of degrees hotter than the surface of the sun. Any spacecraft attempting to fly through this would be instantly crushed and then vaporized. There is no flying through Jupiter. There is only a brief, violent descent that ends in complete annihilation. The beautiful swirling clouds we see from afar are just the gentle, serene surface of an incredibly violent and powerful world.
And for our final myth tonight, myth number 40, a quiet clarification about our search for new worlds. This is the misconception that we have pictures of exoplanets. We see beautiful, detailed images in the news all the time. Pictures of the diamond planet 55 Cancri E or the lava world of Kepler 10b. These images are often so vivid and realistic that we naturally assume they are real photographs taken by a powerful telescope.
But the quiet truth is that, with a tiny handful of exceptions, we do not have any actual pictures of these distant worlds. Exoplanets are incredibly small, incredibly faint, and incredibly far away. They are completely lost in the overwhelming glare of their parent stars. Trying to take a picture of an exoplanet is like trying to take a picture of a firefly sitting next to a giant searchlight from thousands of kilometers away. It is almost impossible with our current technology. So what are the beautiful images we see? They are artists' impressions, or artists' concepts. They are created by talented artists working closely with scientists to visualize what these worlds might look like based on the data we have collected. We can't see the planet, but we can detect its presence. We can measure its size by how much light it blocks when it passes in front of its star. We can estimate its mass by how much it makes its star wobble. From its mass and size, we can calculate its density and guess if it's rocky or gassy. By studying the starlight that filters through its atmosphere, we can even get some clues about what its air is made of. All of this data is then given to an artist, who uses it to create a scientifically informed but ultimately imaginary portrait of the planet. So when you see a picture of a lava world with fiery rivers or a water world with deep blue oceans, you are seeing a beautiful piece of art, a creative interpretation of the scientific data. It's a quiet but important distinction. We know these strange worlds are out there, but for now, their true appearance exists only in the quiet theater of our imagination.
And so, our long and quiet journey through the whispers of myth and the light of truth comes to a gentle close. We have wandered through the familiar landscape of our own solar system and found that it is filled with quiet corrections to our common knowledge. We've traveled to the stars and the galaxies and seen how our simple earthly intuition often fails us in the face of cosmic scale. And we have looked at our own human stories, our tales of conspiracy and science fiction, and have gently untangled them from the quieter and often stranger reality. I hope this journey has not been a disappointing one. The purpose of dispelling these myths is not to take the magic away from the universe. It is to replace a simple, often incorrect magic with a much deeper, more profound, and more authentic kind of wonder. It's true, the asteroid belt is not a thrilling cinematic chase scene. It is a vast, quiet, and lonely emptiness. But to me, that reality, the reality of its immense scale, is far more awe-inspiring than the fiction. It's true, a black hole is not a magic portal to another dimension. It is a one-way street to the end of physics as we know it. And that, I think, is a much more powerful and mysterious idea. The truth is almost always better than the story. The universe does not need our myths to be wonderful. It is wonderful all on its own, in its strange and counterintuitive glory. The beauty of science is that it allows us to slowly, patiently peel back the layers of our own assumptions and our own misconceptions and to catch a glimpse of the reality that lies beneath. And that reality is a quiet, beautiful, and deeply humbling thing. It is a universe of fluting water, of sideways glass rain, of invisible matter, and of a darkness that tells the story of its own creation.
So as you drift off to sleep tonight, Let your mind be at peace with these quiet truths. Let go of the noisy, dramatic myths and embrace the silent, profound wonder of the real cosmos. Think of the true white light of our sun, filtered into a familiar yellow by our own precious atmosphere. Think of the beautiful, lonely silence of space, a silence that protects us from the roar of distant stars. Think of the courage of the Apollo astronauts who faced the real, quiet dangers of space, not the fictional ones. The universe is the greatest story ever told, and it doesn't need any embellishment. Its own quiet facts are more fascinating than any fiction we could invent. And the wonderful thing is, that story is still being written. We are still discovering new things every day that challenge our assumptions and expand our sense of what is possible. There are always new myths to be gently corrected, and new, deeper truths to be uncovered. The quiet journey of discovery is endless, and in that thought, I hope you find a deep, comforting, and profoundly restful sleep. Sweet dreams.